Hello, I'm Datwin. Welcome to part 2 of our augmented reality series. The objective is to generate an augmented reality environment that is interactable. We will use spatial tap gestures to place 3D models into the real world overlaid by a virtual environment. The models can be rotated and resized using a UI menu. By manually positioning these models, you can adapt your scenario to any real-world spaces. In this video, you could see how the selected 3D model from the menu can be placed throughout the environment. You can rotate both the model in the menu and AR environment. You can only resize the model in the AR environment. All right, let's get started. The start file for part 2 is almost the same as the final version of part 1. One main difference is a 3D model folder with 4 model assets that we will use later. In the main app file, add a state variable called menu class that instantiate a menu class. We'll create a menu class later. Pass menu class to content view using the environment modifier similar to AR class. Add another window group with ID menu. This window should call a menu view file, which will also have AR class and menu class passed into the environment. We will create menu view later. Pass menu class to immersive view. Create a folder named classes to store all class files. Move AR class into this folder. Right-click the classes folder, select new file, and create a Swift file named menu class. Open the menu class file. The menu class will help us manage the menu view by storing data and menu-related method. Import Swift UI and RealityKit. Add @main actor and @observable attributes. Create a class called menu class and give it the type observable object. Create a variable root entity to hold all the menu entities. Add a model store that is a dictionary with string as the key and model entity as the value. The store will hold our 3D object. To get the 3D object, we need to load the models. Create a function called loadModelEntity with name and position as parameters. Pass the name parameter into model entity named to get the model into let load model. If successful, print a success message. If there's a position, set the load model's position. Store the model by its name into the model store dictionary. Add the model to the root entity as a child. If it fails, print a failure message. Create a menu view file. Create a view folder in the left-hand menu and add menu view and immersive view files to it. We're going to split the menu into two halves. The left side will have the button, the right side will show the model. Clicking the button with the model's name will load the model on the right side. Import RealityKit. Get AR class and menu class from environment. Go to the bottom preview and give it Windows style automatic. Add AR class and menu class from the environment. Add text menu. Add a H stack with two V stack inside. Add a button in the left V stack. When the button is clicked, it should load up a model entity. Add task. Call the load model entity from menu class. Use toy rocket for the name. We're going to label the button with the text toy rocket. For the right VStack, it should load the model. So let's create a text with the word model. Add a spacer to push the text to the top. Add a reality view to see the model. Add the menu class root entity into reality view to see the loaded model. Check the preview and try out the button. The model is loading correctly. Since we need a few more buttons, let's get the button into its own struct. Create a new folder called Components, and inside create a file called Button View. Import ARKit. We're going to pass the following parameter: title, name, and menu scale. Add environment variable AR class and menu class. Copy and paste the button from menu view. Delete the line preview. When we click the button, we need to clear out the previous model so that the new model can load into reality view. Use menu class.rootEntity.children remove all to remove the previous model. Create an if statement that checks if the name is model. If true, return and do not continue. This will serve as a default button that doesn't perform any action. If the model has already been saved into Model Store, we do not need to reload it. Simply add the model back to Reality View by appending it to root entity. If the model is not in Model Store, proceed to load it in the else block. Place task in the else block to handle loading the model. Replace toy rocket with the name parameter. Resize the model using menu scale parameter with set scale to fit the model better. For the label text, replace the string with the title parameter. All right, let's test the button view and menu view. Delete the current button. Add a button view with the title and name both model. The first button will be a default empty button. Next, add a button called Toy Biplane and scale it to 0.8. After that, add a button for Toy Rocket, Drum Kit, and Guitar. Test the button in preview. If you click the button too fast, you can load two models at once. Let's fix that really quick in menu class. Add a var button disabled equal to false. Go to button view. So we need to disable all button when it's loading. Set button disable to true right before loading in task. Then set button disable to false at the bottom when the loading is done. Button has a modifier called disable that takes a bool and prevent clicking when it's true. Use menu class.button disabled as the argument. Set the foreground color to different colors when it's disabled and not disabled. Add a corner radius to keep the shape consistent. Now go back to menu view to test it. Notice how all buttons go gray when it's loading. This prevents double loading. We're able to select and load a model one at a time. Now let's make some buttons that can rotate the model. Create a spacer to push the buttons up. Add an H stack. Inside the H stack, make a call to rotate button file. Now in component, make a file called rotate button. Add the to class reference. Make a var to access the correct model for rotation. Create two buttons, and in between the two buttons, add a text called rotate. The button will access a method called rotate from menu class that we will make later. Go to menu class to create a var called selected model with the default string model. Whenever we click the button, we need to save the selected model string. Go to button view. Access menu class.selectedModel and set it to the var name. Now go to menu class to work on the rotate method. Create a func named rotate with entity y rotation as parameter. The y rotation will let us know if it's rotating in the positive or negative y-axis. Create an angle and divide it by pi by 8 for the degrees change per button press. Use SIMD with angle and axis to get the rotational change as let rotation. Add the rotation to the current rotation with entity transform.rotation. Go to Rotate Button file. The entity that we want to apply the rotation to is the model that is selected. Access the menu class model store. Get the name from the menu class.selected model. Use the name as a key for the model store. Pass a -1 for a rotation to the left in Y rotation. For the label, we will use an image with a preset arrow shape that points to left. Now, add the same disable button modifier that was in the button view. To make the right button, duplicate the button and change the Y rotation to just 1 and left to right. Go back to menu view. Rotation is now working. If we hit the rotate button when the select model name is equal to model, the app will crash because there's no key in model store with the string model. We should only allow the rotate button to appear when the selected model is not the string model. At the top of this stack, check if select model is not model, then show the H stack. Notice how rotate does not appear when the select model is model, and it will appear when you select a real model. Now that the menu model is working, we need to spawn the AR model. Go to AR class file. The menu class has its own model store for keeping the loaded model. We now need a model store for the AR class for the model that will be placed into the AR environment. Add var model store right under root entity. It makes sense to load the model to the AR model store when we're also loading the model to the menu model store. The place to do that is in the button view file. Duplicate the menu class.load model. Change menu class to AR class. AR class doesn't have load model entity as a method. Let's go into menu class and copy the same load model entity. Go to AR class file and paste the load model entity. And that's it. The reason why we gave AR class its own load model entity is because it will save the model to its own AR model store. Now go to button view. Set the load model entity to 1, 1.2, negative 1.75 for the position so that the model can spawn in a good location. Since the scale for the AR model will be larger than the menu model, change menu scale to AR scale. At the top, add var AR scale. Now go to menu view. For all the buttons, add AR scale with these arguments. To test the button, you need to run the VisionOS simulator since AR class and menu class are both needed. Go to Content View. We need to open the menu view when the immersive view is open too. Add Open Window from the environment. Add Open Window ID menu under Open Immersive Space. Now you can hit play on the simulator. Clicking on the different button view loads to model. But rotation only seems to be working on one of the model. Let's connect the rotation button to the AR model. Go to Menu View File. We are in the Rotate button file. We already have buttons to rotate the menu model. We can also use the same button to rotate the AR model. Copy and paste the menu class.rotate method. Instead of using the menu class.modelStore, we'll replace it with AR class.modelStore. Do this for the right button too. To test this, we need to run the simulator. Both the AR and menu model is rotating correctly. Currently, now we can only use spatial tap to add cubes after scene construction is used to create a virtual world. We're back in AR class file. We're going to make two tables that can accept spatial taps so that we can test placing objects on the table. Create a function called addTable with x, y, z, size, depth, color as parameters. Give it a mesh and material and name the model entity as table entity. We're going to give it collision, and we're going to set the position based upon the X, Y, Z parameters. Give it input target component, hover effect component, and physical body component. Lastly, add it to the root entity. Change the depth to size. Go to immersive view, add the two tables with the same argument shown. If you spatial tap on the table, you can spawn cubes on a surface without scene reconstruction. Instead of spawning cubes, we want to reposition the AR model into the spatial tap's location. Go down to spatial tap gesture, comment out AR class dot add cube. Check to see if the menu class dot selected model is not model, the default. Then get the current selected model from the model store of the AR class. Set the model's position to location 3D. At the top, pull in the menu class from the environment. Go to preview and add dot environment menu class. Let's check the simulation and it should work. The model is loading correctly and it's loading where we click on the table. Some models are too big and we need to scale it up or down. Pause for a moment and see if you could figure out how to add buttons to scale only the AR model. Okay, let's work on adding scaling buttons to the model. In the menu file, we want to add some scale button on top of rotate buttons. Add HStack and scale button. Duplicate the rotated button file and rename it scale buttons. Go into the file and change the struct name to scale buttons. We're only scaling the AR model, so delete the menu class model store. Change rotate to scale method that we will make later. And delete the second parameter. Change the image to minus for scaling down. Change size to 40. Change text to scale. Go to the next button and do the same, but the image should be a plus. Go to menu class file to create the scale method. Go to the bottom and create a function called scale. Add 3 parameters, entity, magnitude, and is scaling up. Get the entity's transform as var transform. Get the scale factor by checking if it's scaling up. If yes, use the magnitude, else use 1 over magnitude. Apply the scale to the transform with transform.scale multiply equals scale factor. Now save the new transform to the entity's transform. Go back to scale buttons. For the minus button, set its scaling up to false as a second argument so that it would decrease the scale size. That's it for the code. Hit play simulator to see it in action. Scaling up and down is currently now working. The code is complete. Now let's test the app in Vision Pro. Let's load up our first model. We're going to place the model on the table. And now we're going to resize and rotate. Now let's place the model on the generated environmental mesh. And it works. Let's place it on the bed. Congratulations, you have successfully created an app to place 3D model anywhere in a room. Customize your room with any 3D models you want. Thank you for coding with me. See you in the next video.